All right, practice numbers 1 and 2. On practice 1, Rakisha here claims that the equation f of n equals 5n minus 7 is the function notation for the sequence that is represented by the formula a sub n equals negative 2 plus 5 parentheses n minus 1. And James doesn't understand how this could be the case. So in part A, we want to help James here take that equation and show how it becomes the function notation. So we've been doing in our notes. It's the same thing each time where you're going to distribute and combine like terms. So I'm going to start off by distributing a 5. As I do that, I get 5 times n and 5 times negative 1. And then from there, the 5n, there's no like terms to bring with it, so that just comes on up front. But then negative 2 and negative 5 are like terms. They don't have a variable with it. So negative 2 and a negative 5 combine to give me negative 7. So that is how that is transforming into what Rakisha said. Now we're going to graph the function and label the first 5 values of the sequence on the graph. Unfortunately, we don't have a lot of room, so I'm going to go ahead and move the next part of that for part B up here and get myself maybe a graph. Maybe not. See if the grid could get me to 7 or it doesn't. Okay. So to graph this, I'm going to go ahead and make a rough sketch of it because I don't have any graph paper here. Okay, so to do that, the first thing I'm going to do is I'm going to go ahead and get a point out of there. Now, I'm going to go ahead and get what we call the y-intercept. To calculate the y-intercept, as we talked about in our notes today, is to set x or set n to 0, plug it in, and then work it out to see what output you get. And that's going to be where the graph crosses the y-axis at. So I'm going to go ahead and plug in to that function, and we can use the function form or we can use the explicit notation form, and plug in n as 0. And I promise you, either one you get it, we're going to get the same answer. 5 times 0 is 0. 0 minus 7 is then negative 7. So what I have found then is what we call as our y-intercept, because that occurs when x is 0, or in this case, n is 0. So go to your graph and just kind of sketch it out. 1, 2, 3, 4, 5, 6, negative 7 is down here. So that's 0, negative 7, that's 1 point. Now to find the next point, well, after 0 comes, say, 1. So I'm going to do now the exact same thing, but I'm going to plug in 1. Essentially what I'm doing is making a table. 5 times 1 is 5. 5 minus 7 is negative 2. So I'm at 1 comma negative 2. So then I'm at 1 comma negative 2, which is right about there. And I would keep going because they want the first 5 points, so I would do f of 2. 10 minus 7 is 3. So 2 comma 3. Right about there. And so on. Now I'm about to run out of room here because when I do the next one, 3, 5 minus 3 is 15. Sorry, 5 times 3 is 15. 15 minus 7 is then 8. I'm starting to get way off the graph. But then you should start to see as I get these to appear on a line. Okay? So that's the graph of it. Number 2, determine whether each table of values represents a linear function. For those that represent linear functions, well, write the function. Okay? So on letter A, to determine if it's a function or linear function, I'm going to go through and calculate the first differences that we had done yesterday. That would determine if it's linear or not. So we're going to see from 4 to 18, 18, 23, 23, 29, is it consistent? If it is, we are linear. And the first difference says 18 minus 14 is 4. Everything better be 4. And right here, we can say no. So this is not linear because I don't have it being consistent, okay? That needs to be the same number throughout, and it's not the same constant value. So letter A is no. Letter B, from 2 to -1, I drop down 3. So I need to see a -3 for all those. From -1 to -4, I drop down 3. And -4 to -7, I drop down 3. So that is consistent. They're all -3. So then that is a linear function. Now for the last one here, I'm going to go ahead and do it, and then I'll come back around. 11 to 16, that is a difference of 5. 21 to 16 is a difference of 5. 26 to 21 is a difference of 5. So that is consistent. So we can say that that is also linear. Okay. Now, after that, we want to go ahead and write a function for each of these. Now, how do I write a function for each of those? Well, I don't have a lot of room here, so I'm just going to write it, say right down below. I'm going to do graph B, or sorry, table B right here. I'm going to go ahead and say, use that explicit formula that we've been using. You need to know what the common difference is, which we do. On letter B, we found the common difference to be -3. And we know what the first term is. It starts off at 2. And once I have that, I just need to go ahead and rewrite it over into function notation. So to do that, I'm going to distribute the -3. And then I'm going to combine like terms and put it into that form. -3n's nothing to do with it. And then 2 plus 3 is giving me a 5. Okay? So negative, hold on here. What did I do wrong? Give me a second. It should be 3n plus 2. And where am I messing up then? I have to pause on that and come back to that linear one for you. So we're not for 2. -3. Because the answer should be -3x plus 2. That should be our answer right there. I'm trying to figure out why it's not working from there. Let me see here on the other one for letter C before I tell you right or wrong. Is it because the first term is sequence? I should be starting at -1. Let me see here real quick on the other one, and I'll come back to you guys. Okay, so then on the other one, it's because I started the sequence at 1. So let's say -1 minus 3 and -1. That would be why. That makes sense. Okay. So I kind of did a small mistake and I didn't pay attention to that. Right here, where the sequences should start off with a value, term number of 1. And I had accidentally not paid attention. I did 0 and starting with then 2. So what I should have started is my sequence actually starts off here at 1. So therefore I should have used the value of -1. So make sure we watch that. And then as I do that, I then end up with that plus 2. -1 plus 3, that's giving me that plus 2, okay? Because then on the last one, it starts off with 1, so I'm going to use 11 then for that a sub 1, for the term number. So I'm going to do the same idea. I'm going to use 11 here, and I found a common difference of 5. And then I'm going to go ahead and change into function form by distributing the 5. And then combining like terms. 5x out front, and 11 minus 5 is 6, and that is the correct answer. And all is because of what we were starting with. I didn't pay attention on that one, okay? So you're then good to go.